Alright, hello everybody. We're going to do a kind of a unorthodox video today. This is going to be a mixture of a postbag video and a kit build, just for fun. This is also sort of an apology video. I didn't do a back to basics video this week because of technical issues with my computer, which are now solved, but I've kind of fallen behind, so I need to catch up. So sorry for the lack of a back to basics video this week. We'll get back on track next week. Anyway, so what I have here is HV1 high voltage DIY kits. This is the second, I guess third batch of these little arc lighter kits that I've ordered. There was the first one that was an abysmal failure, and then there was the second one that worked really well. And then there are these, which I'm actually really excited about because they seem to be a fairly high quality build and variant. So I don't have any instructions for it, but I think we can probably figure out how to do this. So that looks like it's going to go there. We've got a bunch of various different leads here. Yeah, I'm just jumping right into this. No fanfare, no PDF, no nothing. We're just gonna jump right in and see what happens. So let's get my thingy. We got this. Where's my flux gone? Why is the flux gone? There it is. Alright, so that's everything we need. So we have pretty standard components for this sort of setup. We've got, what is this? 1N4007, interesting. That's not a high-speed diode. I wonder why. Oh, this is a TIP31C. Okay, so that's a power transistor. I believe the 31, I don't recall if it's PNP or NPN, so let's find out real quick. So we'll go ahead and throw this into the component tester and remind ourselves what a TIP31C is. NPN. So the 41s must be the PNP. But anyway, it's an NPN transistor. I should have known that from the previous builds that were NPN transistors. We've got a little switch, a slightly beefier resistor here. What do we have? Orange, orange, black. So that's 3, 3, and then a multiplier of 0. So no extra zeros. So that's a 33 ohm resistor there. We've got a big capacitor here. We don't see any capacitors in the other kits. Interesting. So we've got a capacitor. It's a little 470 micro 16 volt capacitor, so that's going to be on the low volt side for sure. Some power terminals for power input, a switch to turn the thing on and off, and a screw and a nut for the transistor to couple it onto this little heatsink. So I should probably figure out, there it is, there's my heatsink compound, so we'll go ahead and grab that as well. Alright, what should we start with? Well, we have the transformer here. This is the same kind of step-up flyback. I think it's called a flyback transformer. Same kind of idea as this, only this one is potted in resin and all self-contained. So we got the small wire on this side, a big wire on this side, and then a small and big wire here that have actually already been soldered together here at these far ends. So that clearly lines up here. We've got a thick line, and then a thin and a thick line, and then a thin line. So fairly self-explanatory there. That's going to go there. These are the outputs. I think I'm just going to start at the back of the unit here and just work my way forward. That should work. All right, so we'll start with the power device thing here. I'll solder that into place. Nice big chunky tracks, absorbing a lot of heat, making it a little difficult to solder, but I like that because it means that we won't have a lot of I squared R losses or heat dissipation across the tracks for things like, well, it's basically just power losses due to resistance of the tracks. So the beefier the tracks, the less power you're going to lose from the resistance. Alright, that looks alright. Remember to stay in shot here. Alright, so the next thing we'll do is we'll throw the capacitor into place. We've got positive lead here, and then this kind of looks like it's demonstrating a stripe of some sort. So that's just going to go right down in there. We want to make sure let's just go ahead and fold those down like that, because that needs to be laying flush to the board. And we'll follow the same procedure here. I'm going to solder the positive side because it's not attached to a ground plane. Then we'll go ahead and reflow that solder. Get the capacitor nice and flush. And then we'll solder the other lead. Alright, then we'll grab some cutters here. We'll go clip that off, clip that off. Do I want to trim those off? Yeah, I think I will, but I want my heavy-duty snips for those. So I'll go ahead and grab these. This is probably going to ping up into my finger and hurt. Oh, no, not too bad. Okay. I'll trim this one off too. There we go. I may take a file to those to make them a little nicer. Alright, so the next component we'll throw on here will be the switch. So we'll just clip the switch into there. It's not particularly accessible. They could have used one of those switches with a higher button, but that's alright. Let's just continue here. Not wanting to waste too much time. Just want to throw this together and see how well it works. So, nice and easy soldering. Very decent. Nice board. It's taking the solder nicely. The components are nice and clean, so I am fairly impressed thus far with this kit. So we'll just continue trimming there. Oh, sorry. I was banged the table there. Knocked the whole thing out of alignment slightly. Alright. Next we'll do this little 33 ohm resistor, big chunky 1 watt resistor, and I'm going to go ahead and grab my component lead bender here, and it looks like 0.6 is about right, so drop that into the, oh boy, okay. It's supposed to work for the larger components, but it doesn't quite fit. Oh, we'll make it work, there we go. I probably could have just done that with my fingers and had a much better result, but I've got the thing, so I may as well try to use it. Alright, so doing a normal thing, we'll solder one end of that resistor into place, level it out, there we go, and we'll solder the other side into place, like so. Excellent. This is proceeding along smoothly. We're only 5 minutes into the video and darn near done. There we go. Well, not darn near done, but it's coming along fairly well. Alright, so we got the diode now. I don't think the pitch on that one is going to be... Yeah, we basically have to fold the leads of that diode straight down, so we'll go ahead and do that. I know there's some people that are wincing thinking about the strain being put on the package, but it's not that big a deal. Alright. Diode's in place. I'll go ahead and solder that. I don't need to level this one because it's got a really solid connection. The negative side of the diode is going that way as it's marked on the board, right? Yes, okay. We'll clip that off like so. I'll do a video later on where I sort of, I'll reverse engineer one of these and do a schematic and a little blurb on how they work. I just gonna do my, oh, that's not thin enough. Okay, well, let's use this. Just need something to kind of guide as I bend these pins down. So I just kind of, there we go. Use the tweezers as a bending guide there. Didn't get it quite perfectly straight, but that's all right. Just make sure everything aligns before I start soldering. It used to be a little bit, yeah, that'll be fine. All right, so we'll grab the heatsink compound here. Hopefully not make as much of a mess as we have in the past with this stuff. It only takes a very small amount. And again, I end up with far too much. And a big mess. So, let's grab a paper towel here. And clean this up. I swear I'm gonna waste more of this heatsink compound to not being able to really control the flow of it, because it separates really badly. Maybe I should give it a stir and like keep it in the refrigerator or something. I don't know. Alright, so get that back into the board. That worked reasonably well. Well, darn it, I need to go get my screwdrivers. Jump cut. Alright, jump cut complete. Screwdriver obtained. Ooh, I just singed myself on the soldering iron there. So we'll go ahead and put this nut on, like so. I wish I had some thread lock, but I have 3 of these, so I can work on them later. Alright, and then we'll just grab the nut on one side and get a nice strong tighten down on that. And the heatsink compound is oozing through the vias on the board. That's alright though. The more the stuff spreads around, the better it'll conduct the heat off of the transistor. I like how they've sort of integrated a heatsink into the board rather than having you have to build an external one. Alright, and then we're just on the final step of throwing the transformer onto the board. So I'm just going to go ahead and feed these wires through their appropriate vias. I'm having a little bit of trouble with this one, so what I'm going to do is trim off the end here, because I think the way they twisted it is making it harder to get through the holes. So I'll just nip all of them down a little bit there. I'll put the big one through there, a big and little one through the middle one, and then the little one through there. Brilliant. Alright, now, what did I do with the needle nose pliers? Where did they go? Oh, is that one? I gotta put them all the way over there. Okay, there we go. So let's go ahead and pull this stuff through. Almost there. Excellent. There we go. Okay. And then I want to put the zip tie through, or zap strap, or whatever you prefer to call them. I'm going to do it the other way. I'm going to do it this way. I'm going to come up through there. I'm not doing this on camera. So come up through the bottom. Yeah, that's better. And then we'll go through here. Oops. Cooperate, you. I almost kind of want to glue it into place rather than zip tying it, but we'll go with the zip tie on this one. If I come up with any groundbreaking ways to change the way they're built, I'll do a blurb about it later. Anyway, let's go ahead and run this into the grippy bit, if we can get it to do so. There we go. Alright. Much easier to zip tie this one into place than the previous one. Still a little challenging to get it as tight as I'd like, but yeah, I guess that's alright. Maybe I can use a combination of tools here to kind of get it extra tight. There we go. Much better. Alright. We'll just clip that extra bit off there. Alright, now we just need to solder these into place. Yeah, my soldering, actually that's set quite high at the moment. So what I'm just going to do is I'm going to flow a nice generous blob of solder onto the via there and just let it sit for a bit to boil away the enamel on the magnet wire there. Did that work? Yes, indeed it did. Perfect. Alright, and we'll do it over here. Trying not to melt the zip tie. And the same thing, just hold it there for an arbitrary length of time. Just have to wait for the enamel to burn off, boil off. Working on it. The thicker wire here, the two wires are going to be a little bit more difficult to get to work, so I'm going to add a little bit of flux here. Kind of try to encourage it to flow onto the wires. I think that helped quite a lot. Let's see, are you... No, you have not yet. Come on. Let's see, are you cooperating yet? You've done the small wire. Let's get you onto the large wire now. This one's being very difficult. So what I'm doing now is I'm just kind of rubbing it with the soldering iron, trying to get the enamel to go away just enough for the solder to start doing its thing. There we go. Much better. All right. Gonna touch these up with a little bit more flux real quick. There we go. And one last one. This one is a thinner wire. Boy, I can talk. I'm gonna do YouTube professionally. I'd better learn. This is the thinner wire, so it shouldn't take as much trouble to get the enamel to go away, so that the solder can get onto the wire. Of course, no, it seems to be trying to prove me wrong. That's alright. There we go. I believe that is good. I'll just grab my meter real quick. set it to continuity, and all of these should have continuity. Yep. Huh. This one does not appear to be doing... Okay, so that first one, I actually haven't succeeded in getting the solder to flow onto the wire here, so we're going to have to work on that one a little bit more. So going with the same tactic of kind of rubbing at the wire with the tip of the soldering iron here to try to damage the enamel just enough to encourage the solder to finish flowing. This should work now. Yep, we're good to go there. Should also be continuity across there. Excellent. We're good to go. Alright. Just gonna clean these up with a little bit more flux. Make sure the solder isn't peaky. And just nip these off. There's the output. Now these output wires need to be bent fairly straight, and then you gotta put a little kink in the end. And then you can kind of manipulate them to get about, I think the good gap is about 1 centimeter. There we go. That should be good. Alright, now we just need power. Where can I steal some power? I think what I will do is I'll just reach over here. And I will cannibalize power from this unit. I'm even going to be super lazy, and I'm not going to bother desoldering it. I'm just going to nip these off. I need to figure out a better way to power this one anyway, so clip those off. Grab my wire strippers. We'll go ahead and strip these. There we go. Ooh. Yeah, that's what I'm going to do. Be right back. I'm going to grab some tools. Alright, and I'm back, and I'm going to get to use these crimpers that a friend of mine named Kevin was very kind to get me. They're interchangeable jaw crimping pliers, ratcheting crimping pliers, and basically they just crimp a wide variety of ends and bits. I can do ferrules, I can do insulated end terminals, I can do spade terminals. In this case I'm going to be doing the male DuPont pins, which will be making an appearance in a post bag that hasn't been released yet. But basically what you do, this will be the first time I'm doing this particular one, so I just need to make sure I'm doing it correctly. So you gotta place the terminal in like this, I believe, yes. We'll just get it so that it's gripped, and then you take the end of the wire and Basically what you want to do is take the wire and slide it up so that the insulation gets gripped by the pokey bits in the back, and then this center area gets crimped down onto the wire. So this will be my first time doing it with this particular tool, so hopefully it goes well. There we go, that feels about right. Then you just give it a squeeze, and it should be, oops, I bent the heck out of it trying to get it out of the tool. That's not good. That looks like it should be good. And then this piece here, plastic bit, comes down over top of it like so, I believe. That's all bent out of shape. Weird. Let's keep trying here. Can't quite get the pin to line up. There we go. Oh, that almost worked, but that's... I'm having trouble getting my new toy to work. That's a little upsetting. That little spike there isn't... There we go. Let's try this one more time. Otherwise we may abandon the attempt at using the crimper. I'll practice off camera a little bit to get it working. Why are you being problematic? Okay, well that's kind of refusing to go on. Maybe I used the wrong set of jaws. Maybe it needed to be this one. I may have used a too small section of the crimping tool. Oh, you know, oh, I see where I went wrong. Okay. This has to go here. Fascinating. All right. So when crimping these, it's a lot easier to put the terminal into the jaws of the crimper first. Kind of get a grip on the thing that you're crimping. Of course, it's also important to make sure that the wire is properly aligned. All right, let's try this again. Only this time without the oops. Maybe we can get this one to work better. So that's going to go up in there. And the wires are getting spread out now. Typically you don't have to tin wires when you're putting them into a crimp. Something that's getting crimped, but you can if you desire. Let's see. So that should, oop, well that didn't work at all. So I think I had the size right the first time. Oof. Show the back of my head to the camera there. Pick this thing off the floor. There we go. Okay, so I guess I had the right crimp size the first time. So let's try this again with the smaller crimp. Tighten that down and pop it loose. Let's see if that worked this time. Oh yeah, that's much, much better. I bet it'll even go into this thing now with no fanfare. Okay, apparently there's still some fanfare for those. I'll figure that out later. But I have the pins now, so that's all I was really after. I guess we can turn off the soldering iron and move it off to the side here. Oops. Let's not melt anything. Okay, and then we need a small flathead or slot screwdriver. And positive is this side. These terminals are tightened all the way down, so we'll have to loosen them up first. Positive goes here. Let's see how well our hasty build works here. Plug the negative terminal in that side. There we go. All right, now if I engage this switch, we should get an arc. Brilliant. Let's bring those in a little bit closer. I think that was a little too far away. There we go. There's a little bit of a delay. And that starts getting really warm really fast. Perfect. And I'm sure that it will still quite happily ignite vapor. Yep. Cool. So, oh, holy crap. I wonder how many of you were screaming at me for not actually finishing soldering the thing. Wow, that is a very amateurish mistake there, Chris. How could you do such a thing? Alright, so let's keep those far away from each other because those batteries have a lot of energy in them. And let's finish soldering the transistor there. Boy, I am really embarrassed. That was... Wow. Be honest in the comments. How many of you were screaming at your screens saying, "You didn't finish the transistor, you moron"? I'm sure there were some of you. I know I'm saying it to myself, although I can't go into the comments section myself. I guess I could go into the comments section myself and say, "Hey, you forgot the transistor, you moron." But there we go. Let's go ahead and give that another try with the transistor soldered. I doubt there'll be any difference because I mean, it worked fine with the transistor not soldered, but now it has a much more secure connection. So let's go ahead and try this again. This time without the oops. Name that movie. That away. Brilliant. And no, Fanatical, I am not going to touch it. You want to touch it by your own. Yeah, so there we go. Just a quick throw together of an arc lighter. I really like this one because I think what I'll probably end up doing for some sort of permanent fixture is actually try to work it into the case of one of these USB power banks. Probably put it this way so that that would be a lot more intelligent doing it that way. But yeah, you know, nice 18650 battery with the arc lighter circuit here and mounted onto the top somehow. But yeah, I really like that result. I like this design far more than the other two designs. And yeah, that provides a really nice arc. I'll have to experiment with various things that I can set on fire with it. Anyway, thanks so much for joining me. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting based on your watch habits. right here will be the Kit Builds playlist, and right here is a link to Patreon, which you can use to help me buy things like this to show you guys how to build and screw up on, and then you can make fun of me. Anyway, thanks so much for watching, and we'll see you next time. Bye-bye.